Hello, everybody. Good morning, good afternoon, good evening, or just a plain good day from whichever part of the world you guys are joining. And thank you so much for joining. Before we start, a huge shout out to the DPS 2022 team for putting together this wonderful, absolute magnificent series of sessions, bringing together so many diverse people globally, so many interesting topics. Absolutely a huge round of applause, DPS 2022 team. That is a job well done. Absolutely well done. Without much ado, we will, begin our session. I am going to talk today about edge computing and, how do we achieve that, especially on the Azure ecosystem with the help of SQL. So let me share my screen. And yeah, let's begin. I'm going to put this in the presentation mode. Just bear with me for a couple of minutes while this is loading. Typically, it takes a bit of time. All right, so here we go. Yep, so we will start about machine learning on IoT with SQL Edge, which is also, commonly termed as AI on the edge or edge computing. So this is about me. I'm the Microsoft MVP for AI now, second consecutive year. And I also lead the AI IoT offerings out of SEA region in Avanad. I'm the Code Without Barriers mentor for the, upskilling program undertaken by Microsoft with girls in tech and women who code and all of those good platforms. I'm also a champion for sustainability and AI for good, and you can always connect with me on my Twitter handle, which is at fuzzymind1, or on LinkedIn. So this is how the session will flow today. We will just discuss about edge and edge computing fundamentals. We will look at what is all the noise about machine learning at the edge. And then we will look at some integrated edge solutions like an Azure ecosystem. We will then dive deep into SQL Edge and then how we achieve machine learning with SQL Edge. We'll of course see a demo which is explaining the concepts of SQL Edge and IoT Hub and devices and modules and Docker containers. And then we will look at some of the futuristic landscape for Edge AI, some of the benefits, some of the challenges, and of course, there will be question and answers. So let us look at IoT edge and edge computing. Okay, so what is all this edge? I mean, when we talk of IoT edge, where is this edge located, right? So all of us know about IoT in general, Internet of Things, IoT devices, all our smart devices aware of each other, are all our smart devices talking to each other and making decisions intelligently, intuitively, right? Optimally. So when we talk of edge, what is this new dimension added in the Internet of Things universe, right? So IoT edge is where sensors and device communicate real-time data to a network, right? Okay, so the thing is, normally what happens is if the the point where the data is processed, okay, is at the device itself, then that is called edge. Okay, so normally, let's think of your GPS tracking devices, right? So typically, what happens is data is streamed from these devices. Could be like your CCTV cameras, could be your smart, watches or your wearables, right? Your smart wearables. So data is collected or streamed from these devices, and in order to make intelligent decisions or some route optimizations or give you some other AI enabled information forecasting, this data which is collected from these devices is then sent to the cloud. So there will be some ecosystem which is deployed in the cloud. It could be a virtual machine, it could be a REST API which is taking that data, and so on and so forth. But nevertheless, the idea is that data from these devices is streamed to the cloud from where the processing takes place, and then the results are sent back, and then the device displays the result to you. All right, so this is your Internet of Things ecosystem. But what happens with edge? The turning point is the data is processed in the device itself. So imagine that, the device which is collecting the data also has some memory, okay, also has a AI model deployed right in the device for the analytics and the data processing to take place and then immediately give you the result. So no need of this round trip. Like I'm streaming smart vision or a smart vision camera is streaming all the real-time video stream to the cloud. Decision is being made in the cloud and stream back. No, I am collecting the data at the device itself, and at the device itself there is a keyframe processing of my video stream, and immediately I get back the results. So imagine the high throughput, right? And with the onset of 5G, okay, with the announcement of 5G in many countries, this is actually very achievable, right? So you can actually process large amount of data absolutely real time. It's not even near real time, right? I mean, it is absolutely real time. And then it can be a very immersive, comprehensive experience to the user. So imagine you are wearing a HoloLens, and then the HoloLens is immediately, as you're walking or as you're going into some uncharted territory or unknown terrain, the HoloLens is able to capture the latitude longitude of the location where you are and immediately tell you some information about how optimally located are you from your destination, or do you need to reroute and stuff like that. And that is without any delay. Like as you're walking, it actually predicts the next optimal point you should take or route you should take. Okay, so imagine the amount of reduced latency, okay, and also the amount of immersive experiences this gives to the user. And again, it's this HoloLens example for your rerouting and all seems a bit run of the mill, right? I mean, we don't really appreciate the expedition, we are not really able to appreciate this, this fact that okay, this is really beneficial. But imagine in a very sensitive scenario, especially in an industrial or manufacturing domain, where split second decisions can make or break things. Like for example, safety of your workers, safety of the machine itself. If there is an alert, the production line has to be stopped like at that instant. Okay, or probably some worker is hovering very close to some security area or danger area, then immediately a warning should be fired. And whatever heavy machinery operating, or there is this in construction area especially, they have these lifts operating, elevators operating, carrying cement and whatnot, so that has to be immediately stopped or stalled. So this split second decision making, imagine how important it becomes, especially if you can compute it. So the data is coming in, immediately you're computing, giving out the results without waiting for the data to be sent to the cloud, and then analytics takes place and comes back. Maybe by that time, the production line would have actually produced one or two faulty products, or the impact could be cascading into something very major. Or maybe if the security alert is not triggered at the correct point of time, then it could be fatal to the workers, or there could be other potential hazards involved, right? So which means, because of this entire idea of edge computing and AI at the edge, or analytics at the edge, apart from just throughput, and apart from latency issues, and apart from giving this immersive, comprehensive experience, it also helps to, because of this split second computation, it also helps to make your workplace actually smart, your manufacturing, your workplace is smart and safe and secure for the users, for the the entire industrial ecosystem, the entire manufacturing ecosystem. Okay, so that is why edge computing is important, because as we state here, as I reiterate here, it involves processing the data near its source without sending it long distances. So there is this concept of edge to cloud replication, right? So we'll discuss that in a bit. Okay, but for introduction, right? The thing is that edge computing is important because of the quality or because of its capacity to process data at the source itself without having to send it or travel it to some cloud server where it will undergo processing. And as I said, right, the example which I had given was like if the factory is using some machines on its assembly line and their inputs are processed using a cloud-based server, then because of the delay, there could be some real significant safety issues or could be some real significant production issues. So, if, I mean, imagine a situation where, as I said, right, split second decisions need to be made without even batting an eyelid, and then in that case the importance of edge computing, the significance of edge computing really comes out. Okay, so it as it is correctly said, right, the data will have to travel yards instead of miles, correct? So it not only saves time and bandwidth, right, but it is also very secure, and it is also important to make that near real time or almost instantaneous decisions. So what are the IoT edge devices we talk about, right? I mean, we discussed about edge and edge computing, but what actually enables that computing? Because there has to be data. I mean, for all the computing in the world which you want to, all the smartest AI algorithms which you can potentially build will still rely on the data, right? And this data is made available to us by these IoT edge devices. So the data, the devices which actually give us the data, it could be your vision cameras, it could be your Arduino chips, it could be your GPS sensors, it could be your wearables, it could be your HoloLens, it could be your smartwatches. All these these devices which stream data and have the capacity to also process the data in some form of the other or the other are IoT edge devices. Okay, so as you can see, right, IoT edge device is internet enabled and typically comprised of sensors. So the data which these devices stream or send out, right, it gets sent through a messaging system. Like there's a MSMQ or AMQP messaging system, right? And then, it is processed at the IoT hub, which we call it. In the case of Azure, it is the Azure IoT hub, where it will get these data in the form of some predefined protocols like AMQP. Okay. So the IoT edge device is internet enabled and comprised of sensors. So these sensors, they actually collect the data and then pass it to the processing unit, okay, which is like in our case, it is the collection of modules which are deployed at the IoT hub, which then process that information and then give out some intelligence, some analytics, some insights, those kind of things. Okay, and a collection of IoT devices together, okay, can actually process the data in a distributed fashion. So it's not like only one IoT device will bear the entire brunt of computation, but it could be a series of IoT devices where one IoT device is storing, one IoT device is the brain and is doing the analytics, and one IoT device is actually helping to receive the result and then take the action and so on and so forth, right? So the work could be effectively distributed among a collection of IoT devices, edge devices. So, there are these two distinct terms. One is IoT device itself, and one is the IoT edge device itself. So, I have pointed out the difference very clearly here. IoT device is a physical object that has been connected to the internet and is the source of data. So, imagine your smartphone. Okay, and it is the source of data. It is connected to the internet and then it is doing some processing at the cloud for some of your benefits, right? So let's say you've developed an app which is translating, okay, so which is speech to text or text to speech kind of stuff, or just even generating your sign language, for example, right? So in that case, whatever the user is saying or speaking, that is first, that audio transcript is first extracted, then sent to the cloud. So in that case, the app on your mobile, so your mobile becomes the IoT device. It has a connection to the internet, okay, and to the from that connection, it connects to the cloud server where it will stream the audio transcript. From that audio transcript, I'll be generating, either text translation or speech to text or sign language and sending the result back. So my mobile phone with my app installed becomes my IoT device, but it has the connection to the internet where my brain is deployed, right? So this all this text translation services and all of that good stuff. On the contrary, an edge device is where data is collected and processed. So imagine that you are having some sort of I don't know, a wearable or a GPS device or some sort of an a Raspberry Pi where the data is collected and also processed there itself. So you're not making a call to any surveys or any REST API deployed on the cloud, but then it is processed in the device itself. So there is a collection of all that intelligence which is deployed in the device itself. So your data, the device collects your data, processes there itself, and then gives you back. So in the case of your mobile phone, the previous one which we talked about, the app which is collecting your audio transcript processes the audio transcript in the mobile phone itself without having to reach out to the cloud, and then gives you the result immediately. In that case, the your mobile phone, if it is processing the data in the mobile itself, in the device itself, will become an edge device. And if it is actually making a call to the server, to the cloud for processing, then it becomes an IoT device. So I hope the difference is clear, right? And so edge devices, we will see how they are able to process the results at the data at the edge itself. That is by collection of something which is called as Azure modules, right? So these are nothing but basically Docker containers which are built and deployed locally on the device, and then they take care of all the analytics and data processing. Okay. And then of course, because as you can see, devices, we'll have the device twin, something which is like similar in concept to the your Azure digital twin. So it's a digital representation of your physical world. Okay, so then we can control some of the states, like how often you should replicate the message from edge to cloud. Okay, because it might so happen in some cases that I might want to retrain my model. Okay, so I have gotten some data, and I have created a model, and I have deployed it on the device itself. But what if I want to track my data drift now, or I want to retrain my model? So for that, I want to rely on broader ecosystem from the cloud where there are other services, the message bus and events and all taking place. So then I can also control the amount of time when the model is replicated from edge to cloud. At what point of time do I really want to replicate? Because it might so happen that not all of the time your device might have internet connection, right? So because if you want an edge to cloud replication, you must have a stable internet connection. Imagine a situation where soldiers typically are wearing HoloLens, and that HoloLens is enabling them to make especially at night time, that HoloLens is tracking their coordinates and then telling them if they are in a friendly territory or in a enemy territory, or they are close together with their mothership, their troops, or they are straying away from their troops, that kind of stuff, right? So in that case, uh, but not all of the time they will have connection to the cloud, right? I mean, for this kind of edge to cloud replication to take place. So whenever they have a stable internet connection, all the analytics which is done at the edge can now be replicated to the cloud and shared across. Okay, so shared across to all the different battalions and all the different troops and stuff like that. But when they are just traveling on their own without a stable connection to the cloud, then the edge, that is the model deployed at the edge, it takes care of tracking their lat long, and then telling them whether they are in a friendly territory or in an enemy territory. And as soon as they are connected to the cloud, then they can jointly share intelligence, various troops, various battalions, various different um, uh, categories of soldiers. They can share intelligence among themselves. So this is the entire play of IoT devices and IoT edge devices. As if we move to the demo, I think you'll understand more. Okay, so machine learning at the edge, right? So now, the thing is, see, IoT devices or IoT edge devices, either of them, they just are the harbingers of data, right? They are just the enablers of collecting data. What to do with that data, or what sort of information can we give with that data, or insights that that data plays, could be pattern recognition, could be forecasting, could be uh, 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 sort of giving some intelligent analytics, okay, or predicting something. So all these kind of things and much more can be done by analytics, advanced analytics. So I'm putting, like, all the data processing, reporting, and advanced AI, object detection, vision, linguistics, all under the umbrella of advanced analytics. So especially, machine learning or AI will come here and come in play here, and then it will be able uh, to do these kind of actions on the data. So if let's say if it is a video stream, okay, then in tracking the video stream, breaking it down into keyframes, and then identifying, I don't know, images from the keyframe, identifying some topics being spoken about in the video stream. Those kind of analysis could be done. If it is documents or images or text data, then recognizing keywords, key phrases, named entity recognitions, custom entities, a relationship between entities, those things can be done, right? So these things on top of the data, these kind of analytics on the top of the data, will be brought together with the help of the AI. So going back to our very first example, right, where we sort of talked about people working in a factory, and how instant analytics will help us take care of stuff. So imagine that we have a constant sensor data from the machines, which tracks the electricity consumption. Okay, so electricity consumption from the machine is tracked, various machines is being tracked. And then using this analytics, what we can do is we can actually predict the machines which are more energy intensive. Okay, and then we can actually look at a time series of all the historic values, and then see that what was the most optimum operation of that machine. So maybe the machine, when it was started at 9 a.m. on Monday and stopped at 12 p.m. on Friday, with a downtime of around 12 to 14 hours. Okay, and that time it consumed the least electricity and gave the max output. So these kind of analytics, these kind of permutations, combinations will be possible with the help of AI, right? So this is what the AI analytics will be able to do. It will be able to recommend some optimum operating parameters for the machines. It could be able to also recommend the predictive part maintenance, like some parts close to wear and tear, and again highlight security alerts. Okay, or let's say pattern recognition, meaning if one particular mistake at the production line has caused xyz damage. So let's say let's take let's take an example where we are manufacturing t-shirts. This is also actually one of the demos which I'm going to showcase. So let's take an example where we have a t-shirt manufacturing firm, and because of increase in the humidity, there was probably the humidity went above 65%, and because of that many of the t-shirts suffered in quality and had to be recalled. The next time, if the humidity is crossing or touching that mark or hovering near that mark, the analytics should be proactively able to trigger alert from its past learnings. So, not only instantaneous feedback, but also this kind of recurring patterns or proactive analytics can also be done with the help of analytics on the data at the edge itself. Okay. So then what is this edge AI? So now we know the role of machine learning, why AI and ML comes into play with all these, data and edge devices. So what is edge AI, or which is also called as edge computing, right? So as we know that, AI relies on data. So without data, there is no AI, and your model is only as good as your data is, correct? So edge computing, now it brings into view a new computation paradigm. Okay. So which enables, like, we already had AI, right? So AI has been around for now almost like half a decade, meaning, competitive AI with all of its glory, especially with OpenAI and BERT and many advances in your vision and text and stuff like that. So in all its glory, AI has been around for like strongly around for like half a decade now. Okay. Now bring in edge AI. So edge AI is the, as we talked about, right? It's the capability of processing all these wonderful information which we have right at the edge itself, right at the source of the data itself. So this AI and edge computing have opened up a new frontier altogether, what we call as the edge AI or edge computing, right? So it allows for faster computing, it allows for better data security. Well, that's a contentious point, right? Data security, as we will discuss in the futuristic scope for edge AI and edge computing. But as of now, just imagine that instead of sending over all your data across the cloud, okay, so on the internet to the cloud for processing, isn't it better that your data is processed in the device itself? So you don't have to apply a lot of extra encryption on the data before you're sending it across the net, because once you're transferring data over the net, right, internet, right, I mean, it is susceptible to a lot of insecurities, susceptible to a lot of threats, right? So that is why if your data is directly processed at the point of generation itself, then of course there will be better data security. And then because you are concerned with only one device getting out the data, okay, one source of data, then there also will be easier control over the entire operations, correct? And then because you are processing small data at one point of time, which is also helping you to keep the operating costs down. So if you look at the costs of some of the IoT edge devices, typically are, I don't know, very low. Okay, so edge AI can also help in overcoming some technology challenges associated with it. Okay, so for example, very complex, huge AI models, right? They can be broken down into smaller constituent pieces, so that each piece can do one part of the work, right? One part of the computation. So edge AI also helps us to sort of simplify the AI algorithm. Okay. And then of course, as I said, right, it can do whatever AI can do, but closer to the data source, and with lesser quantity of data as well. So that not only makes it fast and secure, but also it doesn't require an internet connection all the time, because your code is directly, your logic or your brain is directly running at the source of your data. So now how to do this? I mean, talking all these wonderful things is one thing, right? But how to actually bring this into action? So this edge computing or edge AI, building this wonderful brain near to your data source, how to do that? So which is what we call as integrated edge solution. And one of that possible solution is with the help of Azure Machine Learning and Azure SQL Edge. Okay, so there are a lot of ways to do this. I mean, it's just Azure SQL Edge, as I said, is one part of this ecosystem which we are going to cover today. But otherwise, there are a lot of pieces for this integrated edge solutions. Like, you could have your computer vision, you could have your video analytics, and you could have your GPS devices, all working in tandem towards giving you some, real time analytics. So a lot of possibilities, right? So one aspect of this integrated edge solution we are covering today is with the help of Azure Machine Learning and SQL Edge. So as we can see here, right, by 2025, which is not far from now, like a couple of years, 75% of enterprise generated data will be processed at the edge. And you can see how quickly that has risen. So it from less than 20% in 2018, we are looking at more than three quarters by 2025. Okay, so that equates to around 80 billion connected devices generating 180 zettabytes of data. Okay, and as I said, the challenges for edge solution, right? I mean, they have to be super fast, so which is keeping the latency low and working with the bandwidth constraints. So because you're constrained with the memory footprint of the devices, the bandwidth which is available to you, so you have to work within those confines, within those constraints, and then still have to handle a variety of data, various types of data. At the cloud, at least you know that you can deploy very high computational GPUs, very powerful N series and deep learning machines, which will be able to compute all the heavy data which you send to the cloud. But when you want to process the data at the source itself, then the memory footprint of those devices could be very small. The bandwidth constraints would be there, but you have to work within those constraints and still, give out the analytics and give out the results instantaneously. Okay, so again, as I said, right, because edge devices may not have a constant connection to the internet. Okay, so they would be in and out of the network. So in that case, how to maintain the state? So when they are out of connectivity and when they come back into connectivity, how to have that edge to cloud replication and ensuring business continuity. Okay, so these are some of the challenges for edge solutions, and which is why there are a variety of tools coming in play here to mitigate these challenges. One of them is Azure SQL Edge. So what is Azure SQL Edge? See, it's nothing different from what your Azure SQL server is. Okay, it's just that it's a SQL, so which is an optimized SQL on the edge. Okay, so which means it will efficiently optimized for storing data from all of your IoT edge devices. A variety of them, right? We talked about them already. Vision cameras, or could be your CCTV cameras, your wearables, your smartphones, anything which is connected and computing data at the edge itself, right? So this is an optimized relational database for IoT and IoT edge deployments. Okay. Now again, when you create an Azure SQL Edge database, you can absolutely connect to it the normal way you do your Azure SQL Server using your SQL Server Management Studio. So most of the syntax which you're going to use, right, like your select, insert, and all of the wonderful T-SQL syntax is still valid for SQL Edge. It's just an optimized Azure SQL for IoT. That's the only difference. So which means it provides capabilities for high performance data storage and processing. And then, it has capabilities to stream process and analyze even non-relational data such as JSON data, graph data, time series data. Okay, and that's how it becomes an ideal choice for most of the modern day IoT applications. Okay, and it is built, as we can see, right, on the latest version of SQL Server only. So which means the syntax remains the same. It is just that it can also process non-relational data, like, as we see here, JSON, graph, and time series. Okay. And because it is built on top of our normal SQL server, which is how portability between edge and cloud becomes very easy. So if I have to transport data from Azure SQL Edge to our normal Azure SQL on the cloud, then data portability is easy because it is essentially built on top of the same SQL Server database engine. So what are the deployment models for SQL Edge? Meaning, like we create an Azure SQL platform as a service, or you create a SQL, I mean, you create an Azure SQL server, or you create a managed instance of Azure SQL. So that way, how do you create Azure SQL Edge? So Azure SQL Edge is created, there are two options, okay? Either, we go into the Azure portal, we create an Azure IoT hub, and then there are a lot of marketplace module options available in which we provision an Azure SQL Edge, or then you can also deploy it as a container instance. So there will be a Docker container instance available in Docker Hub, and we can actually pull it from there, or then deploy as a standalone container on a Kubernetes cluster. Okay, so you've connected deployment from Azure IoT Edge itself, or then you have disconnected deployment where you can actually pull the images from Docker or standalone Kubernetes cluster. So when we talk of Azure ML and Azure SQL Edge, so the tagline which Azure uses is run natively integrated machine learning at the edge and get the most out of real-time analytics. So the previous use case which I was talking about for the soldiers wearing HoloLens and using it to give them analytics about where they are and how close they are to their mothership or their friendly territory, or are they navigating into maneuvering into unfriendly uncharted waters, right? Those kind of things. So in that case, this is not any random example I'm giving. We actually implemented this sort of use case for one of our clients, right? And in that case, the SQL Edge was used to store all the metadata of the users, right? So of the soldiers, like the soldier name and the type of vehicle they are using, and their rank, and whether they are on foot or they are traveling in a vehicle, those kind of things, right? Or they are operating some machinery. So all of these metadata was stored in SQL Edge. And there was another, schema in SQL Edge itself, which was storing some other coordinate, which was actually, getting the real-time data about vehicles, about the soldiers' location, latitude, longitude, altitude also, if they are climbing, right? And then we were actually doing analytics. So there was another analytics service which was combining the real-time data which was being sent with the metadata which we had about the soldiers. So some like a master data which we had, combining it with the real-time data which is coming in the form of Neo4j entities and relationships, and then doing intelligent analytics about various soldiers and maps and locations and latitude, longitudes, right? So the processing of the latitude, longitude, and proximity analytics was being done using Azure ML, okay, clustering algorithms, and whereas the storing and invocation of the ML models was done using Azure SQL Edge, okay. So what typically happens is, with the help of SQL Edge, we can run the applications closer to the data source. It is what we've been talking about most of the time, like how the data is collected from the HoloLens and then processed or stored in the modules which are present on the HoloLens itself. So Azure SQL Edge is deployed on the HoloLens, and that the latitude, longitude is stored in the SQL Edge itself. And then Of course, Azure machine learning will be able to leverage on to create the models quickly and easily. And then Azure machine learning and Azure SQL together will integrate with each other. So SQL will be there for storing the information closer to the data source. Azure machine learning will be then in charge of building the intelligent models, and then the intelligent models are deployed on the device where the data is stored, and then we will be able to then integrate these various frameworks, okay, and then make decisions, right? So here they natively integrate with other Azure services. So let's say I have some the requirement for cognitive services, vision services. So because all this is an Azure ecosystem, SQL Edge as well as Azure Machine Learning, right? So they will be able to integrate with each other, as also integrate with open source frameworks and languages like MLflow, TensorFlow, Python, R. Okay, and when we are deploying all of these to the edge, you will do it with the help of ONNX, Online Neural Network Exchange, right? Which is you're actually compressing the actual model which you're building. ONNX in ONNX, you're compressing that so the size of the model is reduced before you're deploying it onto the edge. So this is, integrated edge solutions are always better together, right? And for Azure SQL Edge, what data you can handle? Time series data streaming, okay? Then native data movement to Azure, and then of course it has inbuilt performance and security also, okay? And it shares the same Microsoft SQL code base. With Azure Machine Learning, you can have Auto ML, you can have Responsible ML, you have an open and interoperable framework, and integration with other Azure cognitive services and other Azure ecosystem, right? So both of them are Azure offerings. They are, they integrate well together. They gel well together, and then they can also operate with a plethora of other open source services, thus, enabling us to take advantage of all the rich storage as well as processing solutions available in the Azure framework. Okay. So, and of course, it is pay as you go, right? So, whatever VMs we are whipping up, whatever modules we are developing, all of them are pay as you go. So, as long as you're using the compute, as long as you're using the analytics on the VM, then only you are paying for the usage, correct? So, Azure SQL Edge is only $10 per IoT device, and AML, we know, right? However, how much ever resources we consumed, we are charged for that only, and there is no AML fee for training or inferencing, only for scoring the model, correct? So this is the edge and cloud ecosystem, right? So on the edge, you have various sensors, okay, to gather the data, right? And then you are actually publishing the data to something called as edge hub, right? So all the data which is coming from the sensor using some messaging protocols is mirrored to the edge hub. From the edge hub, it is ingested, so stored in SQL. Okay, so this is storage. See, the storage which is transformation, aggregation, anomaly detection, right? So you're storing that in the SQL, okay? That data which is stored in the SQL, you are analyzing either with the help of machine learning or inbuilt cognitive services like custom vision, face recognition, or Azure ML in the case of your object detection, deep learning, text analytics, okay? So you are then, so the stored data with the help of Azure ML and cognitive services, you're processing and analyzing, okay? And then why it is ONNX runtime? Because the Azure ML model or the cognitive services model, when it is deployed on the edge, has to be an ONNX model. Okay, so a SQL Edge can also invoke that ONNX model, and then once the computation on the edge is complete, it is mirrored to the cloud. As you can see, right? This is Azure IoT Hub. Okay, from the IoT Hub, it will be then you can have data synchronization, you can do synapse analytics and build and retrain the model, as I said, right? Because now once you are let's say you want to improve the precision of your model, then in that case, you will actually need to collect the data from all the devices which are connected to the IoT hub and not only one of the devices. And then you will be responsible for retraining your model using Azure machine learning and then deploying it back on the edge. Okay, so edge to cloud replication has to take place, just that it need not be connected all the time. Like in the case of our dear soldiers wearing the HoloLens, they won't be in network connectivity or internet zone always, right? But as soon as they are in the connectivity network zone, they will be able to then exchange information, and if there is has to be any retraining done. We can also talk about this in an in a retail setup. So imagine that you have again the similar project we have already done using Azure IoT Hub and SQL Edge. So imagine that you have sensors installed on shelves in a retail chain. Okay, so imagine there's this huge retail giant and it has various branches, and in various cities of a particular country, and then it has various shelves, okay, which on all of its branches, right? So where sensors are installed, and then these sensors are actually trained for object detection. So let's say they can detect all your FMCG items like pasta and jams and candies and jellies and coffee and beverages and so on and so forth, right? And then I should be also able to track the inventory, like item added, item removed, and my inventory slipping below the threshold and stuff like that, right? So in that case, the sensors which are installed, okay, or the cameras which are installed on the shelves, if they are able to process this locally on the device itself, right? Like for example, new packet added in the shelf, is it a pasta, right? Or is it a wheat pasta, or is it a chocolate, that kind of a thing, okay? But over the time, let's say new pasta varieties are added to my shelf, okay? So right now I was able to detect different types of pasta like fusilli and penne and so on and so forth, right? But now suddenly whole wheat pasta also comes into picture, in which case it looks like chocolate, and then I actually want to now retrain my model with this new variety of pasta, or a new type of chocolate comes in which looks a bit different, and my object detection of chocolate is now poor. It is slipping below the threshold, accuracy threshold, in which case I want to now retrain my model on different other chocolates, and then again deploy it on the edge. So in this case, then cloud comes into picture, right? So what I'll do is, I will every day I will check like what is the accuracy of my model at the edge, and I will compare it with the threshold. Okay, so let's say if it is slipping below the threshold, then I will check the reason. Okay, which is that item which is slipping below the threshold. Let's say it's pasta. So now that all the pasta images which were wrongly interpreted, which were wrongly detected, I will send back to the cloud. Okay, so from the SQL Edge on the Azure SQL Edge on the edge, it is replicated to the cloud, and on the cloud I will retrain my model with now the new images of pasta or chocolate or whichever new item, and then redeploy them on the cloud. So this exchange is being shown. Okay, so from the SQL at the edge, it is being replicated, maybe for retraining, as we said, right? New pasta has come in, or new type of chocolate has come in. So then I'll be replicating from the edge to the cloud, and then I will probably take all my actions in the cloud for retraining and building some sort of analysis, and then redeploy it back to the edge, to the device to do. So that replication we can actually handle, like how often I want to replicate, probably once in a day, probably in the case of this retail scenario, it's not every day that a new variety of pasta gets added, right? So maybe once in a week I should be able to exchange information from edge to cloud. So those kind of settings, right? So it's a very, very beautiful ecosystem, the give and take of information. So now let us look at one demo. So we've talked a lot about all all of these beautiful things like processing the data right at the source of the data, and then how replication takes place. So let us look at a working demo where we will be invoking a regression model with Azure SQL Edge. The model has been trained using Azure machine learning, so built using Azure machine learning. Then we have compressed it, converted it to ONNX format, and that ONNX format is now, invoked by the Azure SQL Edge to make decisions. Okay, so the demo, I am terming it as SQL Edge and ONNX crossplay. Okay, so the demo storyline is as follows. Okay, it is based on a wind turbine farm that leverages SQL Edge for data processing on board the generator. So the generator in that wind turbine that actually generates the electricity, right? Based on the wind speed and stuff like that. So there is this Azure SQL Edge on the generator itself, and then that Azure SQL Edge is used for data processing. Okay, so it will actually take a decision based on the wind speed and the turbine speed, and take action appropriately, whether to increase. If the throughput is decreasing, then what action to be taken to increase the blade speed and stuff like that. Okay, so I hope all of you know what a wind turbine looks like, and then the turbine speed is controlled by the SQL Edge, okay, based on the different surrounding conditions. So the demo, we will walk through, resolving an alert being raised due to wind turbulence at the device. So because of the wind turbulence detected at the device, there is an alert raised, and how to resolve that alert using Azure SQL Edge. So we will train and deploy train a model using Azure machine learning and deploy it to SQL Edge that will correct the detected wind wake and ultimately optimize the power output. Okay, so the model which we have trained will deploy it to the SQL Edge, and then the edge device is able to detect that there is an alert being raised due to the turbulence, and then it will take appropriate actions to correct that, and then again optimize the power output. Okay, now the training data set which we have used here, right? I'm going to show you the code also, the demo also. The training data set, it contains trends that will enable us to detect the existence of wake in a wind turbine. Wake meaning, sort of a disturbance in a wind turbine. Okay, so there are two main conditions that influence the disturbance in that, okay, turbine. So there are two things, like there is a wind, there is an overall wind farm, and there is a turbine wind direction. So the wind farm direction and turbine wind direction are both 40 to 45 degrees overall. Okay. And then turbine speed standard deviation and wind speed standard deviation, these two features in the training data set, if they have been too far apart, like, not matching for more than a minute. So the turbine speed standard deviation, which means, the standard deviation of the turbine itself vis-a-vis the wind in the overall farm. Okay, if they are too far apart for more than a minute, or the wind direction of both of these are between 40 to 45 degrees, then we detect that there is a presence of wake. Okay, there is a presence of some disturbance, right? Okay. So for example, so if how we define wake is present, so the turbine wind direction is, between 40 to 45 degrees. And then as you can see, right, the turbine speed and the wind speed deviation are quite far apart, right? Or so in this case, wake is present, meaning turbulence is present. Not present means the turbine wind direction is off, like it's not between 40 to 45. And then as you can see, the turbine speed and the wind speed are not too far apart. Here it's like they are miles apart. Here they are not too far apart. So in this case, disturbance is not present. Okay. So I will show you the data set now, and the demo itself now. Let me again, go back to my screen. I've stopped sharing. Let us look at so this is my, so this is my experiment. So this is, my machine learning model. Yeah, so this is my machine learning model. I have coded that model using Azure machine learning. So here, this is our normal Azure portal, right? Nothing on the edge right now, correct? So we will analyze the model to predict wind turbine wake, right? So like when there is disturbance, right? So the parameter actually, which is we are predicting is called as alter blade. Okay, alter blade true or false. That will tell whether there is disturbance, yes or no. Okay, so these are some of the features of the data set: turbine ID, gearbox level, oil temperature, power, generator speed, temperature, torque. Okay, then wind speed standard deviation, turbine wind direction, turbine speed standard deviation, average wind speed, temperature. So a lot of, as you can see, features in the data set. Then we are actually going drilling down into the exploratory data analysis and then taking out significant features, right? So for example, turbine wind direction, right? So turbine wind direction, we are checking, and then we can actually see that, there is a considerable alteration between 40 to 50 degrees. So when the angle turbine wind direction is between 40 to 50 degrees, we can see that there is a considerable alteration here, right? And then see alter blades is the final prediction which we are going to do, the linear regression which we are going to predict based on all the different features like standard deviation and turbine wind direction. So based on these inputs, the output which we are going to, the label which we are going to predict is alter blades. Okay. So there are a lot of exploratory analysis which we are doing here for the wind direction angle, then our average turbine speed. If you can see the turbine speed distribution, the average turbine speed is between 10 to 25 kilometer per hour. Then how the alter blade behaves with the turbine speed standard deviation. And as you can see, right, alter blades true and false, they actually have marked rises and valleys and troughs for different angles and standard deviations. Okay, so same way, like we are analyzing a lot of parameters: wind speed standard deviation, how it acts reacts with the alter blade predicted value, right? And then we are actually isolating these kind of things, and then we are actually doing a pair plot for wind speed standard deviation and turbine speed standard deviation with the alter blade, which this is something which we want to predict given the other parameters. Okay. And now we are actually creating the experiment, creating a cluster, submitting the experiment. So as you can see, my experiment has been successfully completed. Okay. And then I'm actually monitoring the experiment and see status completed. And then it is giving me, some of the logs which are there. Okay. So as you can see here, this is my final model. So I have trained the model now. Okay. So here I'm downloading the trained model, and this the trained model is now converted into ONNX format. Okay. Here I've converted the downloaded model into ONNX format. And this model, I'm actually deploying this ONNX model. I'm actually deploying it on the edge device. Okay, so that the generator on the wind turbine, right, which has Azure SQL installed, I'm actually installing this model on that edge device. Okay. Yeah, so this ONNX is the model. Okay, so I've trained the model to predict the alter blade condition true or false based on my other parameters like the turbine wind speed, standard deviation, and all of those things, right? Wind speed standard deviation, turbine standard deviation, the wind direction, turbine angle, turbine wind angle, these kind of input features. And with the help of that, I've trained a model to predict whether the alter blades value will be true or false. And then that model, the trained model, I'm converting into ONNX and then deploying it onto the edge. Okay, the device which I'm making, right? So I hope we are clear with the Azure ML part. Now let us come to the edge part. Okay, so as you can see, right, whenever we are creating an IoT project, we have to create an IoT hub. Okay, Azure IoT hub, which is where all the devices will communicate with. Okay, and the IoT hub will have, we have the ecosystem for deploying our devices, and then the modules within the devices which will actually take care of all the processing. So this is my IoT hub. Let me go inside and see. As we said, right, in on my IoT hub, I will have edge devices. So these are your normal IoT devices with connectivity to the internet. These are the edge devices where all the processing takes place at the edge itself. So in my edge devices, I have this edge device, which you can imagine that, not imagine. This is the device which has been now in charge of detecting this turbulence at the generator itself. Okay, so the turbine generator has this device installed. So this is the IoT Edge device, okay, which is connected to the IoT hub. Okay, and this device has the Azure SQL installed there. Okay, so you can see, right, if I go here, I will have all these modules here. So Edge Agent and Edge Hub are the default modules which are paramount to the correct processing and correct behavior of all the IoT Azure IoT Edge devices, right? So these controls. So these are the system modules, and sensor module and Azure SQL Database Edge are the modules which we have developed. Okay, so I will just show you a glimpse of how they look like. So as you can see, right, the modules which we develop here, whether it is the sensor module or the Azure SQL database, SQL Edge database module. Okay, so these are nothing but Docker containers. So if you go into the template JSON, you can see, right, these are actually the Docker containers, and you are deploying them or pulling them from the ACR, Azure Container Registry. Okay, so the container registry credentials are given here, the container registry name, password, username, and stuff. And we are actually, these are nothing but Docker containers which we are deploying on that device itself. Okay, in our case, the generator on the turbine. Okay, the device which intercepts the wind speed and turbine speed and all other stuff to take cognizance of the fact whether the alter plate should be true or false. Okay, so as you can see here, the edge hub and the edge the edge hub and the edge agent are system modules, and then our custom modules are the sensor module. Okay, the sensor which is actually getting the data for the wind speed and the turbine speed, and then Azure SQL database which we have taken from the marketplace. So remember, when I talked about, there are two ways of deploying SQL database. One was disconnected, one was connected. So this is a connected mode in which I'm actually deploying the Azure SQL from the marketplace itself. Okay, so this is the Azure SQL database, and this is the sensor module. Okay, the sensor module, right? So yeah, so as you can see right here, and then the sensor module is calling the SQL connection string, okay, to store the data in the Azure SQL database. So the sensor module, it intercepts the wind speed and the turbine speed and stores that data into SQL database. So bases that data, what SQL database does, the SQL Edge database, it does is, bases that data, it will give some alert, right? Like, hey, the wind speed is so and so, and the turbine speed is there is a wake here, okay, and there is this lot of turbulence or lot of mismatch in the turbine output, and I need to correct that. Okay, in which case it will call the model. So there is an alert which is generated because of the different sensor information. So sensor is continuously sensing the wind speed and the turbine speed, and basis that information, it will give out an alert saying, hey, there is something wrong with the turbine, right? Lot of turbulence out there, in which case Azure SQL database will now invoke our ONNX model saying, hey, can you please, give me the decision? Now this is my data. So this is my data for the wind speed. This is my data for the turbulence, sorry, the turbine speed. Okay. And now, can you tell me what action to take? Should I increase the blade speed? Should I decrease the blade speed to optimize the output and correct the alert? Okay. So SQL database now invokes our ONNX model, which we had developed, and then bases the decision which is given saying alter blade yes or no, it will take the corresponding action and then resolve the alert. Okay, so this is the entire ecosystem of how it works like. Now let us see it in action. Okay, so this is our website. Okay, I'm going to refresh it. So you will be able to see the dashboard, models, maintenance settings. Okay. So this is the dashboard where you have a lot of, so these are the wind turbines running, correct? These are the wind turbines running, and each of these turbine here inside in the generator has this device which is sensing the wind farm speed and the standard deviation versus the turbine speed and standard deviation. Okay. And each of this, so each of this turbine has an installed device, okay, a generator on which there is a device which has a sensor that is sensing this parameter. And locally, each of this, so like maybe there are 15 turbines, so they have 15 devices with 15 sensors installed, which sends the data, turbine speed and wind speed. And these devices have locally an instance of SQL, Azure SQL Edge. Okay, so let us take example of this turbine. This turbine has a device which has a local instance of Azure SQL Edge deployed, which is tracking these parameters like wind speed and standard deviation and turbine speed and stuff. And then there are some alerts raised. Okay, so let us look at the alerts. Okay, so it is running query for unit 34, and the alert, as you can see, right, the power generated is actually going down. So expected is this, but actual is this. Okay, right? You can actually see, right? And because the security alert, because let's say I am an operator, I'm not an administrator, which means the security alert is not visible to me. But if I look at the environmental things, so you can see the wind speed and the wind direction are pretty stable. But if you look at the wind speed of the turbine and the wind direction of the turbine, there is a lot of disturbance here. Like you can see, right? This is almost constant, okay? But this one, the wind speed and the turbine is very disturbing graph here. Okay, so which means an alert is generated saying, hey, something is wrong with the turbine. Right now, you take an action. So what action needs to be taken? That action will be told to me. What action to be taken based on all the other parameters will be told by my AI model, right? The one which is in ONNX format. So let me go back to my um, model. Okay, so as you can see, right here, you will be able to see the sensor module. Okay, so sensor module, once I open the sensor module, I will be able to, so let me show you. I'll go inside the sensor module. In the sensor module, you will be able to see that there is module identity twin. Okay, so in that module identity twin, what I'm now doing is I'm actually putting uh, the data here. Okay, the ONNX model which is to be called. Okay, so ONNX model which is to be called, I'm actually putting here. Okay, so ONNX model URL, we will get it once we are deploying that model into blob storage. All right, so I'm getting this model URL. Right now, I'm saving that. Once I tell you the ONNX model to be invoked to correct that action, then we go here, we refresh, and now you can see, right? Yeah, so you will be able to see now that it has been mitigated. So the wild variations in the wind turbine now have been mitigated after my ONNX model has taken decision that yeah, you should be able to that alter blade parameter. It adjusted alter blade, and now as you can see, till this point of time, till my ONNX model was not invoked, the output was quite varying, but now it has been smoothened out, right? As you can see here, it has been corrected. So our model was invoked by the Azure SQL database, and then basis the information, it has taken care of the action to be done, whether to alter or to to reverse the alter the blade true or false, right? And then you will be able to see reports here, dashboard. So in the dashboard, then again, yeah, same thing, alerts have been mitigated now, and then it will, over the time, it will also be able to improve the power generated. Okay, so it has mitigated. So again, you can see, right, it has mitigated, the ONNX model has mitigated the wind speed, and then once the turbine wind speed and turbine wind direction are mitigated, the power output, the power throughput will automatically be optimized, right? Yeah, so this is the use case, how we go about. And as I said, right, this is one scenario. You can imagine, I'm going to show you another demo in which, let's say if faulty production line, faulty t-shirts were produced by the production line, then immediately it should be able to take smart decisions about stopping the production. Okay, so I'm going to show you one small part of the demo here to that effect, like how the production line should be. Okay, so I'm going to maximize this. Okay, and I'm going to show you that, for example, this is the digital replica of the supply chain also, right? And as you can see, the supply chain has various, like for example, these are the retailers. This is the factory where the product is manufactured. So these are the retailers who send the raw material to the factories. The factory manufacture the t-shirts, and they are then sending it out into the shops. Okay, shops and businesses. Okay, so one of the retail outlets has a alert here. Okay, so if, for example, and you can also track, like for example, each mode of transport, what is the temperature, what is the location and stuff like that. Okay, so now we will go to the location where there is an alert, right? Yeah, so this location has an alert, and that alert, we will see that, there is this alert. Why this alert is because of, for example, there is this faulty shipment. As you can see here, green is good, and then this is a warning shipment. Then I can isolate from, this faulty shipment, this faulty this thing, raw material was sent to which factory. So now I know that this factory, right? And then I can actually isolate that factory. Then I can go inside that factory, and I can actually see, like, where, on which production line that faulty t-shirt was manufactured. So look at the level of details which I can go into. Then I can do an historical analysis of the product when it was manufactured. Then I can actually see that, the conditions of the weather, humidity and stuff on all the production lines. And I immediately know that, because of the, probably, the greater humidity was the cause of faulty product, right? And then you can actually predict here, you can predict the impact. So if the humidity keeps on becoming high, I can predict the quality, like the quality will keep on declining, right here. And then I can view the impact. So impact meaning this factory impacted what other outlets. Okay, and then I can actually take a decision to stop here. So estimated financial impact, how many t-shirts, which factories. Okay, and then I will be actually able to reroute intelligently and also stop the production. I will be able to take a decision, like, see, stop line. This is what we are saying, instantaneous decisions, right? Stop line meaning it will stop operating that faulty line, and then it will be able to reroute intelligently. Okay, so when I kill this factory, it should be able to reroute to, like, which other retailers and which other factories will be able to supply me if I'm cutting off one of my factories. Okay, so yeah, so these are like, stopping the line, rerouting intelligently. These are the decisions which can be taken by the help of edge computing. Okay, so what are some of the challenges of uh, AI, okay, edge computing. So what are some of the challenges which we foresee? So as I said, right, future is looking bright for edge AI, right? So because again, as we said, right, from 20%, less than 20% in 2018 to more than 75% of devices and businesses using edge computing, right? So of course, and again, with the help of your 5G technology, many countries have that added boost for edge AI. And a few benefits for edge computing are, like as I said, it is just small footprint, which is data is small, so maintenance is easy. Okay, then your latency and throughput, throughput is very high, latency is very low, and of course, better customer satisfaction because you're getting your results at the fingertip. And then again, it can be scaled out to a large I mean, it can be easily scaled out, correct? And your edge lifecycle management is also easy because of all the edge computing framework which is available. Okay, and again, your return on investment is very huge. It is predicted to be at 5.7% from an industrial AI perspective. Okay, but again, while we look at the future, and it is quite promising in terms of finances, and it is quite promising in terms of your ROI and your infrastructure, various tools and frameworks available. But there are a lot of challenges. First of all, as we know, right, with any IoT device, the data which is streamed, that essentially is of a very poor quality. So a lot of time when we solution for IoT projects, the challenge is in getting real worthwhile data. So a lot of the time, the data quality itself is very poor. Then security, like as I said, right, when I was explaining earlier about security, that is a debatable issue, because when we say that it is better that, instead of sending my personal data over to the cloud via your internet for processing, it is better that I process it locally itself at my device. But because for the cloud and for the internet itself, there are a variety of security protocols and encryption standards, practices, security practices in place that cannot be set true for the devices where your data is stored, right? So there, because the devices itself are, from a variety of hardware vendors, and all of them might have different practices for encryption, storage, formatting, communication. So in which case your security is not standardized. And then because, typically the devices itself are very, like, may not be memory optimized, very small memory, very simplistic. In that case, it becomes very easy to sort of, manipulate the weaknesses in your devices and get your data stolen, as opposed to your internet, where you have a lot of established standard security practices. So actually, the data is vulnerable and easily exploited inside of an edge device. I mean, I'm sure, as it scales up in the future, there will be more standardized practices. But as of now, yeah, data vulnerability is a feature, like one of the areas of concern. And then again, limited machine power, meaning imagine that in scenarios where you have, complex AI or analytics task, where you want to do video analytics, where we want to do deep learning. In that case, the model itself, the AI model, sometimes for sophisticated advanced analytics use cases could be humongous, right? Like the footprint, the memory footprint of those models could be not enough to be, facilitated by the device itself. So because of that, there is limited, AI ML power, as opposed to the cloud, where you can have sophisticated virtual machines and you can have sophisticated, infrastructure to make all your fancy AI possible. But with your edge computing, it's a challenge because of the limited memory and the limited infrastructure of the edge devices. So there are a lot of frameworks coming in as of now, for example TinyML, or a DECI, where they help you compress your state of the art AI ML models and be able to, deploy them onto the cloud without losing some of their intelligence, or without losing some of their sophistication conversation. But yeah, I mean, these things are under experimentation, and right now our edge models are not for complex use cases, they are not as sophisticated as our cloud infrastructure AI models. So with that, I stop my session here, and I would be happy to take any questions. You can, as I said, reach out to me on the chat window, on my LinkedIn, on my Twitter with any questions. And special thanks to Microsoft for supporting DPS 2020. And thank you guys. Have a good day. And I wish you all the best for your further learning sessions for DPS. Thank you so much. Bye bye. Take care. Stay safe.